Welcome to our tutorial on creating a stunning 3D water simulation using Java. In today's video, we'll be diving into graphics programming, physics, and more, all aimed at building an engaging water simulation from scratch. Let's get started. Before we jump into the code, let's ensure you have your development environment set up. We will use Java with the LWJGL, lightweight Java game library, for rendering our 3D graphics. Make sure to download and include LWJGL in your project. Start by creating a new Java project and including the LWJGL libraries. This will allow us to leverage its capabilities for window management and OpenGL context creation. Next, we'll initialize an OpenGL window. This window will be our canvas, where the water simulation will be rendered. Here's how to set up a simple window using LWJGL. Now let's move on to the main loop of our program. We'll render our scene here, continuously updating the window until the user decides to close it. Don't forget to clean up once we're done. This is important to release any resources that we've allocated during the setup. Great! Now we have a basic OpenGL window set up, but we need to visualize our water simulation. To do this, we're going to implement a 3D grid representing the water surface. Next, we need to create a method to render the water surface. This will involve drawing a grid of vertices where each vertex height corresponds to the values stored in our water grid array. To see our water grid, we'll invoke the renderWater method from our main loop. This way, every time we update the window, it will draw the current state of our water. Next, we'll introduce some physics to simulate water behavior. We can do this by applying wave effects to our water grid values. One common technique is to use sine waves, which will create a nice undulation effect. Now, let's integrate our updateWater method into the rendering loop so that the water surface updates dynamically. We'll call updateWater before we render water to ensure the grid is updated each frame. Let's add some color to our water to make it visually appealing. We'll use a simple shader to render our water surface. Setting up shaders can be a bit advanced, so if you need more details, please check out our prior tutorial on OpenGL shaders. For now, just remember we need to compile and link these shaders before we can use them. Let's move on to manage GPU resources. We will generate and bind a vertex array object, VAO, and vertex buffer object, VBO, for our water grid. We're making good progress. Now we need to enable our vertex attributes to utilize the vertex data correctly in the shaders. Let's incorporate the VAO management into our rendering process. We need to bind it before rendering the water surface. We can now see our color-enhanced water. However, we want it to look more natural. Adding normals can help simulate the reflection and refraction effect seen in water. Using normals and a basic lighting shader will give us a more realistic representation of water. For simplicity, we'll apply a basic directional light to our scene. As we continue enhancing the realism of our water simulation, we'll also consider surface interaction, like splash effects when objects collide with our water surface. Let's create a simple method to simulate such interactions. We'll call our splash method from an event listener, which triggers every time the user clicks the mouse button to simulate the water being disturbed. As we finalize our simulation, let's implement some camera controls. This will allow users to navigate around the water simulation to view it better from different angles. Modify the main loop to incorporate camera controls and adjust your view dynamically based on user input, for example, using keyboard arrows to look around. Awesome! We've successfully created an interactive 3D water simulation. This simulation incorporates dynamic waves, user interaction effects with splashes, and navigation controls. Before we wrap up, I encourage you to experiment with different parameters, colors, and effects. This is a powerful base upon which you can build more advanced graphics features, perhaps adding particle effects for splashes. Thank you for watching. If you found this tutorial helpful, please consider subscribing for more in-depth programming tutorials. Keep coding and exploring.